Next thing what we have to discuss is Gauss law, Gauss theorem. Okay, so what is this Gauss theorem here? Now, this is an irregular shaped body. Okay, if this is an irregular shaped body, here positive charges are there and here negative charges are there, then what is going to happen? Just see here. From positive to negative, electric lines of force are going to pass. Electric lines of force are going to pass like this. So this is an arrow going to happen. Now, I am taking one smallest part. This part I am taking. I am taking this part of a irregular shaped body. So in which direction aerial vector is present? In this direction aerial vector is, this small part's area is ds. ds. See, if this is ds, total surface is considered as s. ఈ మొత్తం సర్ఫేస్ ఎస్ అయితే దాంట్లో చిన్న తుంట ds అండి. ఆ ఏరియల్ వెక్టార్ ది వెక్టార్ ఏ డైరెక్షన్ ఉందో పర్పెండిక్యులర్ టు దట్ ఏరియా. దిస్ ఇస్ ద ఏరియా ds. The area which represents a vector will be in this direction, perpendicular to that surface. Now this is ds, and what is this? This is E, and this is how much? Theta. So what is the flux? What is the formula for flux? So you know flux is equal to E dot S, which is nothing but Es cos theta. Because electric field is also a vector, aerial vector is also a vector, but flux is a scalar. So two vectors, if you multiply and you are getting a scalar, it is called as a scalar product, or it is also called as a dot product. Okay, so this is a total flux. If you want to find out, the formula is Es cos theta. Now I want to find out a smallest flux because of the smallest area, which is taken as d phi. Then how much it is going to be? How much it is going to be? Let us see here now. So therefore I take a smallest part d phi, which is taken as E into E dot ds, where d phi is equal to E ds cos theta. Any part you can consider. If you can consider this part also, no problem. So here it is a vector. This is going to be theta, and this is E. The same formula. D phi is equal to E ds cos theta. Okay. So I am talking about Gauss law. Okay. Your mind may be having some doubts. Sir, why do we use Gauss law? ఏం అవసరం సార్ మనకి? Coulomb's law ఉంది కదా. You might be thinking that you have got a Coulomb's law to find out the electric field intensity, and the formula is electric field intensity and force acting on unit charge. Okay, two charges are present, one positive, another positive. This is Q naught, and this is a larger charge which is taken as Q. The distance is R, and we write F is equal to Q naught by 4 pi epsilon naught into R square by Q naught. Getting cancelled here, E is taken as Q by 4 pi epsilon naught into R square. This is the formula which we are getting from Coulomb's law. Coulomb's law. And by using Coulomb's law, you can find out electric field intensity of a single charge also, two charges beside each other, and how to find out the electric field intensity because of a single charge by using Coulomb's law. So this is a single positive charge, and surrounding this positive charge there is a field, electric field, and I want to find out the electric field intensity because of this charge. Now here, this is going to be the radius. Understand? This is going to be the radius. So I am applying Coulomb's law here. I am getting the formula which I have derived just now by using Coulomb's law. There was one charge. Surrounding that charge there was a field. You want to find out electric field intensity at a point. Intensity ఎంత ఉంది, తీవ్రత ఎంత ఉంది అంటే నాకు తెలియాలంటే అక్కడ ఒక పాయింట్ పెట్టాలి, అక్కడ ఒక పాజిటివ్ చార్జ్ పెట్టాలి. పెడితేనే నీకు ఫీల్డ్ ఇంటెన్సిటీ వచ్చేస్తుంది, తీవ్రత ఎంత ఉందో తెలియాలి. ఎండ తీవ్రత ఎంత ఉందో ఎండలు నిలబడితే తెచ్చేది తెలిసేది. నీడలో కూర్చొని బా ఎంత చల్లగా ఉంది అంటే బయట అడగాలి, సారిపోతుంటుంది. అండర్స్టూడ్ వాట్ ఐ యామ్ సేయింగ్ నౌ? సో సిమిలర్లీ, why we have to use Gauss law? Gauss law is used for series of charges. One charge, two charge is there, you apply Coulomb's law. Force is directly proportional to product of the charges, inversely proportional to square of the distance between them. That's Coulomb's law. It fails if it is more than two charges. What will you do now? If it is more than two charges, we will apply Gauss law. You will apply Gauss law if there are more than two charges. Then Gauss law can prove Coulomb's law, but Coulomb's law cannot prove Gauss law. Gauss law is having unlimited possibilities. Coulomb's law, only two charges it is applied. One charge is there means field intensity you can find out by keeping another charge. That's it. Limited to two charges. More than two charges, Coulomb's law fails. Gauss law will come. Gauss law can prove Coulomb's law. Coulomb's law cannot prove Gauss law. Understand? So how do you say that Gauss law proves Coulomb's law here? So I have taken a charge. See, in Gauss law, you have to consider an imaginary surface. ఒక సర్ఫేస్ ని ఇమాజిన్ చేసుకోవాల్సి వస్తుంది. కూలూమ్స్ గాస్ లాలో సర్ఫేస్ ని ఇమాజిన్ చేసుకోవాలి. సో ఒక చార్జ్ ఉందంటే ఒక సర్ఫేస్ చుట్టుపక్కల ఒక ఇమాజినరీ సర్ఫేస్ విచ్ ఇస్ కాల్డ్ యాజ్ ఎలక్ట్రిక్ ఫీల్డ్. సో ఐఎమ్ టేకింగ్ ఎ స్మాలెస్ట్ పార్ట్ ఆఫ్ దట్ ఎలక్ట్రిక్ ఫీల్డ్ విచ్ ఇస్ కన్సిడర్డ్ యాజ్ ds. And you know electric field direction. How do you find out electric field direction? Keep a test positive test charge here. With this it is understood that electric field direction will be like this, and aerial vector direction also same. Aerial vector direction also same. Here, if you want to find out electric field intensity according to Gauss law, a simple definition is flux is equal to net charge by epsilon naught. If you multiply epsilon 1 by epsilon naught with the net charge, then it is going to give you total flux. So by using Gauss law, you want to find out the total flux. What you have to do? You have to multiply 1 by epsilon to q naught. Then you will get the total flux. The simple formula for Gauss law is this one. But what is flux here? Flux, if you want to find out a small amount of flux because of this small area, d phi is equal to E dot ds. Okay, E dot ds. You want the net flux, then you have to integrate. You have to integrate, which is nothing but q by epsilon naught. 1 by epsilon naught times of q net. But net charge is only one charge here. I have taken an imaginary surface. Now, what I have to do? I have to find out the net flux because of this one charge. So I have to integrate d phi here. I have to integrate E dot ds. So integration of E dot ds is nothing but E ds cos 0 in this case, because theta is 0. No, E is also in the same direction and ds is also in the same direction. The smallest part of the spherical surface whose vector is represented with ds is perpendicular to that surface. So this is 0. So we write this as E ds because cos 0 is going to be 1. Okay, so you forget about this part now because I want to find out the only electric field intensity. I want to find out only electric field intensity, this much only. So E is constant. Integration of ds is nothing but q by epsilon naught. What is this? Q by epsilon naught. Then what is integration of ds? If you take a small part in a total surface, that is called as differentiation. What is your name, Babu? Isaac. So Isaac ది ఒక చిన్న పార్ట్ తీసుకున్నాను. లైక్ ఫర్ ఎగ్జాంపుల్ ఒక హ్యాండ్ తీసుకున్నాను. హ్యాండ్లో నా హ్యాండ్ పెట్టిన, ఐజాక్ డోంట్ వరీ, యు ఆర్ గోయింగ్ టు మ్యారీ ఎ బ్యూటిఫుల్ లేడీ అని చెప్పిన. చేయి పెట్టిన అంతే, ఇంత దిస్ మచ్ పార్ట్ ఆఫ్ ఏరియా ఐ హావ్ సెలెక్టెడ్, దట్ ఈస్ కాల్డ్ యాజ్ డిఎస్. అంటే మొత్తం ఐజాక్లో నేను ఇంత చేయగలిపిన, దట్ ఈస్ కాల్డ్ యాజ్ డిఎస్. After 4 years, Isaac came to me, sir, you are really true. I married with a beautiful girl. Now I want to hug you, sir. Muslim hug nahi hai, Urdu hug nahi, wo hagna alag. That is English hugging. So he hugged me and said, sir, you are really true. I am very happy because I got my own girl. I married with my girl whom I liked because I became a doctor. I'm a doctor now. She is also a doctor. Married and her. And now he integrated me. He clubbed with me. Integrated means joining, and hugged with the total body. Then what I am doing now? That small parts ds I combined, not only hand, total body. That is called as integration. So if I integrate ds, what are you going to get? Total surface area of an imaginary sphere. So because this is a single charge, surrounding that single charge, it is a sphere. It's a globe, imaginary globe of field. So if I integrate ds, what I am going to get now? I am getting 4 pi r square, which is called as surface area of a sphere. Is it? It's called as a surface area of a sphere. Now just see here. So E and ds, if you integrate ds, I am getting how much? 4 pi r square into q by epsilon naught. So I am getting electric field intensity as q by 4 pi epsilon naught into r square. So by using Gauss law, I have proved Coulomb's law, because from Coulomb's law also I am getting the same formula. Is it not a wonderful thing? Is it not wonderful thing? Because by using Gauss law, I have explained electric field intensity. I said that at a particular point P, if you want to find out electric field intensity is nothing but force acting on unit charge, which is nothing but F by Q naught. This is the definition of Coulomb's law. And what is the definition of Gauss law? Gauss law says that the total flux, if you want to find out, you have to find out you have to take the total charge acting on that surface. Okay, net charge acting on that surface and multiply with 1 by epsilon naught, then you will get the total flux, and the total flux is nothing but ES, which is product of electric field intensity and surface, E dot S dot product. Understood what I'm saying now? Okay, so I have applied Gauss law for a single charge. Gauss law can be applied for a single charge or a series of charges. Now, the most important topic here where you are getting more previous year questions is a line of charge. I have taken a wire where a series of charges are present now. Okay, a series of charges are present now. I want to find out what is the electric field intensity because of this line of charge. You can't apply Coulomb's law now. It fails. You want to find out electric field intensity because of this line of charges, you have to take one imaginary surface. Now in this case, imaginary surface is a cylinder. Okay, imaginary surface is a cylinder because electric field intensity or the space or the region where this line of charge is getting influence is in a cylindrical shape now. Okay, it's an imaginary cylindrical shape and the length of this wire is L. Okay, length of this wire is L. Now I have to apply Gauss law to find out this one. So to apply the Gauss law, you should know one simple thing that linear charge density. What do you mean by linear charge density? Linear charge density is given by letter lambda. What is the meaning of linear charge density? Linear charge density is nothing but charge per unit length. Next, what is the meaning of areal charge density? Areal charge density is given by letter sigma, which is nothing but charge per unit surface area. Q by S తీసుకోవచ్చు లేదా sigma can be taken as Q by A. Okay, ordinary density, what is the density? Density means mass by volume. Linear charge density means charge by length, and areal charge density means charge by surface area. Next, what is volume charge density? Volume charge density. Volume charge density is given by rho, which is nothing but charge per unit volume. Try to understand these three formulas. These are very basic formulas which are to be understood. Okay, which are to be understood to understand Gauss law in a perfect manner. If you want to understand Gauss law in a perfect manner, you should know these basics. Otherwise, you will never understand. You might have done hundreds of problems, but you don't know what is the basic concept of this Gauss law. Okay, so linear charge density means charge by length. Areal charge density means charge by area, లేదా surface area. Volume charge density means charge by volume. So now I am taking a line of charge. So charge density, linear charge density is charge per unit length. Okay, net charge by unit length. Net charge is nothing but lambda into L. But I have to apply the Gauss law here. Am I right or not? I have to apply the Gauss law in this case. So how I am going to apply the Gauss law here? Try to understand this. It's a very important topic. Nearly 20 questions you can solve if you 20 previous year questions if you can solve if you understand the concept which I am going to discuss now. So here, first of all, try to find out what is the direction of electric field intensity. Electric field intensity a direction lo undi. Simple logic is keep the test charge positive charge here. You will understand that electric field intensity direction is this one. Here also electric field intensity is this one only. Here this one, here this one. Electric field intensity, because you want to find electric field intensity, keep positive charge here, test charge Q naught. See in which direction it is going to move, this direction. Here if you keep this direction. Okay, now I am taking an imaginary surface here. This is an imaginary surface which is taken as ds. Okay, so what is this surface area? Ds. And what is the vector which is representing that surface area? The vector which is representing this surface area, I am taking it as ds, and this is E. So if you want to find out the surface, top surface and bottom surface of the cylinder, here if I take a smallest part of an area, this is ds, and electric field intensity is like this, and the angle theta is going to be 90. So E ds cos 90 is going to be 0. So for topmost point and bottommost surface area, electric field intensity is 0. Flux kuda జీరో. ఎందుకంటే ఫ్లక్స్ ఇట్లా ఇట్లా పోతుంది కానీ ఇట్లా కిందికి రావట్లేదు కదా. ఈ ఏరియా నుంచి దూసుకొని రావట్లే, ఆ ఏరియా నుంచి దూసుకొని పోవట్లే, ఓన్లీ ఇట్లా పోతుంది ఫ్లక్స్. ఈ సర్ఫేస్ ఏరియా వల్ల నో ఫ్లక్స్ ఇస్ పాసింగ్, నో ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ అండ్ నథింగ్. సో ఓన్లీ లాటరల్ సర్ఫేస్ ఏరియా అంటాం దాన్ని. చంబు చుట్టుపక్కల lateral surface area, cylinder chuttupakala, drum chuttupakala, that's called as lateral surface area. So I am applying Gauss law now. Q net is nothing but E dot ds, which is nothing but 1 by epsilon naught of net charge. This is called as Gauss law. There is no rocket science in this. So I want to find out what is integration of ds. Okay, integration of ds, lateral surface area of a cylinder is 2 pi r h. Now here 2 pi r l, because h is nothing but the length of a wire. Okay, so h is height of a cylinder, and height of a cylinder is also equal to length of a wire. Because how much is the length of a wire? That will be the height of a cylinder here. So you got ds as 2 pi r l. So now E ds cos cos 0. Cos 0 is 1. So I write now E ds. Okay. So what is this? E dot ds is equal to E ds cos 0 degrees. So this is last final, you are getting E ds only. So here E integration of ds Q net by epsilon naught. So what is E ds? ds is nothing but 2 pi r l, which is Q net by epsilon naught. Okay, so this is electric field intensity now. Next thing is electric field intensity is nothing but Q net by 2 pi r l epsilon naught. This is going to be the electric field intensity because of line of charge. I used Gauss law to prove this. Understood what I am saying now? Okay, so the simple formula is E can be taken as, okay, E Q by 2 pi r l kada. What is lambda? Lambda is equal to charge per unit length kada. Am I right or not? Then what is charge? Q is equal to lambda L. Okay. So what is the new formula here? What is the new formula? Which is nothing but Q net. Q net is equal to lambda L. So lambda L by 2 pi r L epsilon naught is going to be how much now? Let us see. So LL gets cancelled. So electric field intensity formula, another formula is 2 pi r into epsilon naught. So this is the another formula where if you want to represent the formula in terms of charge per unit length, this is the formula. You want to represent the formula in terms of linear charge density, this is going to be the formula. Hope you are understanding now. This is for line of charge. Now, the most important topic is this one now. We are getting many questions in this. Even capacitor is also dependent on this topic which I am going to discuss. What is that? See, I have taken a sheet of charge. There is a sheet of charge. In capacitors also we are taking two sheets, two plates. A sheet of charge where you are seeing many number of positive charges now. Many number of positive charges where Coulomb's inverse square law fails here because this is a plenty of charges. Millions of charges are residing on this plate now, which is a positive plate. So you can't apply Coulomb's law, it's going to fail. Only one law will work here, that is called as Gauss law. Here also you have to take an imaginary surface. And what is that imaginary surface? That imaginary surface is going to be a cylinder. So I have taken one cylinder now, and here back side also there is one more cylinder here. Why backward also one cylinder and front side also one cylinder, my dear? What is the reason for this? Can you tell me? ఇది Gaussian surface పోదా ఏంది అది ఏంది మ్యాచ్కి ఎందుకో నా దగ్గర రూట్స్ ఉన్నాయి ఏం చేయాలనేది తెలుసు ఏంది అన్ని పోతుంది ఓట్లు ఏందిరా అట్టనా వాట్ ఏ లాజిక్ నౌ జస్ట్ సీ ఓకే ఏం జరుగుతుందో బోర్డుకి నౌ సర్ఫేస్ cylindrical surface another cylindrical surface from the back side. So sheet of charge, positive charge this side, here also positive charge only. So to apply Gauss law, you have to imagine one cylinder this side, one cylinder this side also. Now just see here, I told you that what is the direction of electric lines of force in a sheet of charge. See, to find out that, keep one test charge here. In which direction it moves? This is going to be the direction. That's going to be electric field intensity direction also. So here positive charge you keep, it goes this side. Here positive charge you keep, this side it goes. That is the direction of electric field intensity. Electric field intensity cannot be upwards or downwards. Only this side it is in this direction, from back side it is going to be in this direction. Now I am going to select three surfaces, three different surfaces now. So this is one surface which can be taken as ds, and here also one surface I am taking ds, and back side also one surface I am taking, it is also ds. Now electric field intensity direction is this direction, and even ds also the same direction. Here electric field intensity direction is this one, and ds direction is this one. Here angle theta is 90 degrees, here theta is equal to 0 degrees. So here electric field intensity, that is E ds cos 90 is going to be 0 here. That means because of lateral surface area of a cylinder, there is no flux. There is no electric field intensity because of lateral surface area. ఎందుకంటే ఫ్లక్స్ ఇట్లా వస్తుంది, సిలిండర్ సరౌండింగ్స్ కి సంబంధం లేదు, ఫ్లక్స్ మధ్య నుంచి బయటకు వస్తుంది. ఎప్పుడైతే ఫ్లక్స్ ఏరియాలో ఇలా దూరిందనుకో ఆ ఏరియా తీసుకుంటాం, ఇటు పోతే ఎక్కడ తీసుకుంటాం, యూ కాంట్ కన్సిడర్ దట్ వన్. So now is the topmost point of your cylinder where you can apply E ds cos 0, which is nothing but E ds. Cos 0 is going to be 1. Here also we apply, in this direction electric field is there, and in this direction ds is there. Theta is equal to 0 degrees. So E ds cos 0, which is nothing but E ds. So lateral surface area is nothing here. We don't consider. Only two surfaces we will consider here. So I'll apply here integration of 2e into ds, because this is ds, this is also ds, 2e ds, which is nothing but here. So this is the surface area, no? This is the surface area you have to consider here. Surface area, this is going to be the area of the plate is A. Our surface area can be taken as S or A, anything you can take here. So now see, integration of ds can be taken as S, లేదా integration of dA can be taken as A, because integration differentiation cancels S. Why I am taking S? Why I am not taking length into breadth or side square? Because this is a general formula which can be applied for any surface. Circular surface if you take pi r square, circular surface you take pi r square, square surface you take S will become length into L square, లేదా side square. If you take a rectangular surface you will take length into breadth. That means S can be pi r square, S can be side square, S can be length into breadth. हेलो 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 मैं चल रहा हूँ, तो हलता नहीं करे. చెప్పండి, 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 హల్తో हूँ. Okay, so 2 EDS, which is nothing but Q net by epsilon naught. Understand? Q net అంటే ఎన్ని charges ఉన్నాయి అన్ని తీసుకోవాలి. 500 ఉన్నాయా, 600 ఉన్నాయా, that is going to be the net charge. So therefore here 2E integration of ds is equal to Q net by epsilon naught. So therefore here 2E integration of ds is nothing but S, which is nothing but Q net by epsilon naught. Therefore E is going to be Q net by 2 epsilon naught S. This is going to be your formula. Okay, this is going to be a formula here. Understood what I am saying now? What is the formula here? Epsilon naught is equal to Q net by 2 epsilon naught into A కూడా రాయొచ్చు, because area or surface area both are same. In some books it is A, in some books it is S, whatever it may be. Next I told you sigma is nothing but net charge per unit area. Sigma is nothing but charge per unit area. So here I can write here Q net is equal to how much? Sigma into A. So therefore electric field intensity, a new formula. If you don't want to represent formula in terms of charge by area, you can represent the formula in terms of surface charge density. Surface charge density, which is given by sigma. Therefore Q net means I'll write sigma into A, 2 epsilon naught into A gets cancelled. E is nothing but sigma by 2 epsilon naught is going to be the another formula. Is going to be the another formula for electric field intensity. This is the second formula. This is going to be the first formula. You can apply any formula. per surface area. There are many problems based on this. Now let me discuss about one more concept. So what is going to happen if you take a spherical surface? If you take a spherical surface, what is the charge density? What is electric field intensity for a surface area whose radius is Kepler? Now, here I am taking an imaginary surface which is called as a Gaussian surface, which is ds, and okay, so electric field intensity will be in this direction. Why? Because positive charge is surrounding. Okay, positive charge is on the spherical surface. So on the spherical surface, positive charge is there, means if you keep a test positive charge here, it will go here. If you keep a test positive charge here, it will go here. If you keep a test positive charge here, it will go here. It is always perpendicular to the surface of a sphere, spherical surface. So I am taking here, so this is going to be ds, theta is going to be 0, E ds cos 0 is going to be E ds. Okay, so now I am applying Gauss law on the spherical surface. Gauss law on the spherical surface. So what is going to be the Gauss law? E ds is E dot ds is equal to how much? Q net by epsilon naught. So here E dot ds, okay, so E dot ds is nothing but E ds cos 0. ఇది పోయింది, ఉత్త E ds మిగిలింది ఇప్పుడు. Need not write dot here, just E ds, which is equal to Q net by epsilon naught. So E common out, ds if you consider, it is going to be Q net by epsilon naught. So what is E ds? ds is yes. బహుశా నేను ఏమైనా తప్పులు రాసినానేమో, అందుకోసం దేవుడు తీసేసినానేమో దాన్ని. Okay, so surface area. So this is a surface area of a sphere, that's going to be positive. So charge is here on the surface and radius of this is going to be r. I am taking an imaginary Gaussian surface which is taken as ds, and it is represented with a vector s, ds like this, and electric field is in the same direction. Theta is equal to 0. Surface charge density is nothing but charge per unit area. Okay, charge per unit area, but here charge per unit area is 4 pi Kepler square here. Remember this one, because this is a sphere, no? So surface area of a sphere is 4 pi r square. Volume of a sphere is 4 by 3 pi r cube. You know about this? Yes. So that's it. Now here I am applying Gauss law here. Gauss law is nothing but E dot ds, which is nothing but E dot ds, which is nothing but E ds cos 0, which is nothing but 1. That means E ds is nothing but Q net by epsilon naught. So here integration of ds is nothing but s, which is nothing but 4 pi r square. So I have written now E ds means 4 pi r square, ds place law, integration of ds, which is nothing but Q net by epsilon naught. Therefore electric field intensity on the surface of the sphere, on the surface of the sphere, is Q net by 4 pi epsilon naught into r square. దీన్ని దీంతో మల్టిప్లై చేస్తాం అంతే. So if you want to represent in terms of sigma, your formula will be E on the surface is going to be how much it is going to be? Sigma by epsilon naught ante, plus 4 pi r square. Q by 4, Q net by 4 pi r square is nothing but sigma, na? Okay, you can write like this for a spherical surface exactly on the sphere. Okay, so now let us see what is going to happen inside the sphere. Okay, so if you are taking a sphere whose radius is Kepler, and I want to find out what is electric field intensity at this place inside the sphere, then you have to imagine a Gaussian surface here whose radius is smaller, whose radius is smaller. Now inside the sphere where smaller is lesser than Kepler, smaller is lesser than Kepler. So here inside charge is going to be 0. Charge resides only on the surface. Inside electric field intensity is 0, because test charge lopala eta petto. Test charge can be kept here, then electric field intensity like this outside will be outwards and starts from the surface. Inside no charge is there. So here electric field intensity inside is Q by 4 pi epsilon naught into this small r square is going to be 0, because no charge here. Q is going to be 0. So inside the spherical surface there is no electric field intensity. Electric field intensity starts outside the surface. Okay, now if you consider any spherical surface whose radius is Kepler, and you want to find out electric field intensity outside the surface whose radius is smaller, and that is going to be greater than Kepler. No possibility is there. Why? ఎందుకు వచ్చింది పాజిటివిటీ బయట ఎందుకు ఉంటుంది? Because is a positive charge here and electric field direction will be like this. This is going to be electric field direction, and if you take a Gaussian surface here which is taken as ds and that is also taken as ds, theta is going to be 0, e ds cos 0 is going to be e ds. Now e okay, so now I am applying Gaussian what is that Gauss law I am going to apply here in this case outside the sphere. Then what's going to happen? Let us see. If it is outside the sphere, e ds integration is nothing but q net by epsilon naught. So here e ds means which surface you will take, not the spherical surface, imaginary surface which is in red color. That surface we have to take now. So for that you can consider this as 4 pi r square, because smaller, larger sphere is having smaller radius whose surface area is 4 pi r square. Understood what I am saying now? So therefore e ds is nothing but e 4 pi small r square q net by epsilon naught. Therefore e is nothing but q net by 4 pi small r square into epsilon naught. But you should know one thing, q net that is surface charge density, that is sigma, is nothing but q net by 4 pi capital R square, and this surface area is for the actual sphere kada. Charge density we will talk about an actual sphere, not an imaginary sphere. Charge density దేంది? రియల్ స్పియర్ ది. ఇమాజినరీ స్పియర్ ది ఓన్లీ గాసియన్ సర్ఫేస్ అది. ఇమాజిన్ ది డెన్సిటీ ఎట్లా కనుక్కుంటాం? ఇమాజిన్ అది గాల్లో ఉంది, ఇమాజిన్ దాని డెన్సిటీ కనుక్కోలేము. రియల్ సర్ఫేస్ ది డెన్సిటీ అది. సో వాట్ ఇస్ q net 4 pi capital R square into sigma. So here what is going to happen now? See, E is equal to q net means what will you write? 4 pi r square into sigma. This is 4 pi small r square into epsilon naught. So finally electric field intensity outside is going to be how much? Sigma by epsilon naught capital R square by small r square. This is going to be your final formula for electric field intensity outside the sphere. Hope you are understanding what I am saying now. This is the story of a Gauss law. Now let us go for the topic called as capacitors. So you know that capacitor is having two plates. Capacitor is having two plates. How do you construct capacitor now? So రెండు ప్లేట్స్ ఉంటే కెపాసిటర్ చార్జ్ ని ఎలా స్టోర్ చేస్తుందా? ఇది రెండు ప్లేట్స్ ఉంటేనే చార్జ్ స్టోర్ చేస్తుందా? ఒక ప్లేట్ లో చార్జ్ స్టోర్ జరిగి రాదా? నో 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 నో. I told you in the first class that induction is the process we use in this capacitor. What will you do here? You know, this is a plate which is having neutral charges. All the positive and negative are beside, means it's going to be how much? It is going to be neutral kada. It's a neutral plate, and I am keeping positive plate near the neutral plate. I am keeping the positive plate near the neutral plate. Then what is going to happen? As I said earlier, okay, so what is going to happen here inside? లోపల ఏం జరుగుతుంది ఇక్కడ? Because positive and negative are close, as you keep positive charge very close to the negative charge, very close to the neutral body, without touching it, you create disturbance. So all negative charges, okay, plate ni ila raskunte baga artham avutundi. Plate ni draw chesukuntanu, ila draw chesukuntanu, easy ga artham avutundi ippudu. Okay, so plate ila undi, ఇందులో ఏముంది? పాజిటివ్ నెగిటివ్ పాజిటివ్ నెగిటివ్ పాజిటివ్ నెగిటివ్ పాజిటివ్ నెగిటివ్ కలిసి ఉండేవి. ఇది మొత్తం పాజిటివ్ అనమాట. ఓకే, ఒక ప్లేట్ ని ఇప్పుడు ఇలా చూస్తున్నావు, ప్లేట్ ఇలా కనిపిస్తుంది. అదే ప్లేట్ ని ఇలా చూస్తున్నావు, ఇప్పుడు ఇది ఇంతనే కనిపిస్తుంది. ఇట్లా చూస్తే ఇది కనిపిస్తుంది, ఇట్లా చూస్తే ఇది ఇంతనే. ఆ డయాగ్రామ్ ఇక్కడ గీస్తాను నేను. సో న్యూట్రల్ బాడీ ఇది. ఇందులోంచి ఏమవుతుంది తెలుసా? ఇప్పుడు యాజ్ యూ కీప్ పాజిటివ్ చార్జ్ వెరీ క్లోజ్, ఇట్ క్రియేట్స్ ఎ డిస్టర్బెన్స్. వాట్ టైప్ ఆఫ్ డిస్టర్బెన్స్? హియర్ all negative comes closer to the positive charge because it attracts positive and separates negative because of repulsion. Positive will go that side, and this positive is connected to the ground, and ground is an abundant source of negative charges as well as positive charges, but here we need negative charge because positives are waiting. So negative charges will be there inside the ground. All the negative charge will combine with the positive charge, and this becomes a neutral body. That part is nothing here now. If you keep a positive charge, you are creating a negative charge here, okay, only negative charge, and it is connected to the ground. Now this is called as a capacitor. What did you do here? How did you convert this to neutral body? I converted this neutral plate into a charged plate by keeping one more plate beside it. But I said that when you keep a positive charge very close to a neutral body, that plate will get converted to opposite charge. If the positive plate is negative. This is the diagram of a capacitor. Capacitor having positive plate and another plate is called as a negative plate. So in a capacitor, what is present? One positive plate is there and one negative plate is there, and the distance between the two plates is d, and the surface area is a, and this is a charged plate whose electric field intensity is how much? What is the electric field intensity of a charged plate? గుర్తుందా? Q net by 2 epsilon naught into A. Q net by 2 ఇది Q ఉండాలంటే Q లేకుండా ఇది. So Q net by, okay, so what is the Q net by 4 pi epsilon naught into A. దీనిది కూడా Q net by 4 pi epsilon naught into A. Q net రాయదు, Q అనుకో అంతే. Just keep Q here. Just keep Q because charge, total charge is taken as Q. Here positive charge, here negative charge. So for this plate, this is the what is this? This is electric field intensity. And for the another plate which is negative, this is for positive plate, that is for negative plate. Understood? Electric field intensity because of negative plate. Then total electric field because of these two plates is how much? So I have taken here a positive plate and I have taken a negative plate here, and I want to find out electric field intensity in the middle. So this field, electric field direction because of this plate is in this direction only, which is taken as E1, and because of this plate also electric field intensity is this one, which is called as E2. Why for both this direction only? That is decided by test charge. Because of this plate, if you keep test charge here, it moves like this. Because of this plate, you keep test charge, that is also attraction. This is repulsion. Because of repulsion, it goes like this. Here, because of attraction, it goes like this. Both are going the same direction. Therefore, E net is equal to E1 plus E2, which is nothing but Q by 4 pi epsilon naught into A plus another Q by 4 pi epsilon naught into A. So therefore, E net is going to be పావు కలిపితే సగం అవుతుంది. 2 pi epsilon naught into A is going to be the electric field intensity. Net electric field intensity because of the capacitor is this one. Okay, hope you're understanding what I'm saying now. Electric field intensity because of a capacitor is this one. ఈ ప్రాబ్లం ప్రీవియస్ ఇయర్ క్వశ్చన్స్ లో ఉంది, నేను చేస్తాం మనం కల్ కరీనిరే. ఈ డైరెక్షన్ దో ఎక్స్ డైరెక్షన్ ఈవైకి ఉంది దాని మీద. ఓకే, సో ఈ నెట్ ఇస్ ఈక్వల్ టు Q by 4 by epsilon naught into A. But you know electric field intensity formula is Q by 4 pi epsilon naught into R square. The distance between the two plates is D. Area of this plate is A. Area of this plate is A. But what is the formula for electric potential? Electric potential means 4 pi epsilon naught into R. Telsa electric potential formula? I told you, I think. I told you or not? Gurtunda? Gurtuleda? Okay. Okay, simple ga 2 minutes, 1 minute lo cheppestaru. Electric field intensity em telsa formula? It is nothing but force acting on unit charge. Electric potential and em telsa work done on unit charge. This is a small difference. Here force means Q naught by 4 pi epsilon naught into R square by Q naught. Q naught gets cancelled. From this electric field intensity formula is Q by 4 pi epsilon naught into R square. Electric potential means work done on unit charge, which is nothing but force into displacement by Q naught, which is again force means Q naught by 4 pi epsilon naught into R square into R by Q naught. So Q naught gets cancelled, R square gets cancelled. Electric potential की formula ఏమి? Electric potential की formula ఏమి? Q by 4 pi epsilon naught into R. So E की V की difference ఏమి? ఇందులో ఒక R తక్కువ ఉంటుంది denominator లో. So E V కి సమానం కావాలంటే కింద ఒక R తో డివైడ్ చేయాలి. V కి కింద ఒక R తో మల్టిప్లై చేసే denominator లో it is going to be equal to. Is it understood what I am saying? So if you understand this one, you will understand the capacitor now. Capacitor की formula అర్థం అవుతుంది ఇప్పుడు. So what is V here? See, E is equal to V by D ఇక్కడ. ఎందుకు distance between two plates is D. So here I got the formula E is equal to V by R. V by some distance. E is equal to V by some distance. But here E is equal to V by what distance? Distance of two capacitors. So this is the formula. V is equal to ED, and E I got already. How much? What is the E? E for a capacitor, this one. This is general formula, GF in E because of a capacitor is a formula which we have derived for two plates. So therefore Q by 2 pi epsilon naught into A. అర్థమైందా? ఏమో తప్పు చేస్తున్నాం మనం, సంథింగ్ మిస్టేక్ వీఆర్ డూయింగ్. ఓకే, ఈ బై 2 ఎప్సిలాన్ నాట్ 2 రావాలా, 4 ఎందుకు వచ్చింది మనకి? ప్లేట్కి 2 రావాలి కదా, 4 రాకూడదు, 2ఏ కదా. మనకి 4 ఎందుకు వస్తుంది ఇక్కడ? సో స్ఫియర్కి అయితే 4 వస్తుంది, ప్లేట్కి 2 కదా వచ్చేది. ఈ నెట్ ఈజ్ ఈక్వల్ టు క్యూ బై 2 pi epsilon naught into A plus Q by 2 pi epsilon naught into A. Am I right or not? చూసుకోండి ఒకసారి కావాలండి. Q by 2 epsilon naught into A. Q by 2 నేను 4 వేసుకున్నా, 4 వేస్తే 2 అట్లే ఉండిపోతుంది, 2 ఉండకూడదు అలా, ఏమి ఉండకూడదు అసలు. అండర్స్టూడ్? చూసినావా, నేను ఏదో తప్పు చేస్తున్నానే కదా దేవుడు సడన్ గా స్విచ్ ఆఫ్ చేసింది దాన్ని. Is it am I right or not? See. So now, so V is equal to Q by 4 pi epsilon naught into A into D here. Okay. So ఏంది ఇక్కడ 4 కాదు 2, ఇప్పుడు 2 దీనిది 2, ఒక ప్లేట్ ఇది ఒక ప్లేట్ ఇది. సో ఈ నెట్ ఈజ్ ఈక్వల్ టు 2 యాడ్ చేస్తే సగం సగం యాడ్ చేస్తే ఏమొస్తుంది? పై ఎప్సిలాన్ నాట్ ఇంటూ ఏ ఫర్ బోత్ ద ప్లేట్స్ కి ఇది ఫార్ములా. సో ఇప్పుడు ఈ కి ఫార్ములా ఇది Q by 4 pi epsilon naught into A into D. This is the potential because of capacitor. Okay. So here what are you going to get now from this? ఏం అర్థమవుతుంది దీనివల్ల నీకు? Q is equal to V అట్లా పెడతావు, epsilon naught A by D వస్తుంది, అంతేనా? Is it okay what I am saying now? పై వస్తుందా? పై రాదు కదా ఫార్ములాలో, పై లేదు కదా ఫార్ములా, పై ఉందా ఫార్ములాలో? పై లేదు, పై వేసుకున్నాను, అది స్ఫియర్, ఇది కన్ఫ్యూజ్ అయిపోయినా నేను. ఏమైంది ఇక్కడ? పై ఉండదు, అంతే. ఏముంటుంది ఇక్కడ? Q by 2 epsilon naught A 2 epsilon naught A. సో 2 to 1 half అంటే Q by epsilon naught A మిగులుతుంది, అంతే. అదే ఏంది ఇంత తిక్కగా వస్తుంది నేను ఆలోచిస్తున్నాను, ఎందుకంటే చాలా హై టెంపర్లో ఉంటుంది మైండ్, నాకు అర్థమే కాదు. ఆవేశం ఎందుకు తగ్గించుకోవాలో ఎట్లా తగ్గించుకోవాలో అర్థమే కాదు. Q by epsilon naught A into D. అండర్స్టూడ్ వాట్ ఐ యామ్ సేయింగ్ నౌ? సో ఇది Q ఒక పక్కన తీసుకుంటే epsilon naught A by D ఒక పక్క వస్తుంది, ఇంటూ V వస్తుంది, ఇది వస్తుంది అనమాట. Therefore Q is equal to CV. Q is equal to CV formula. What is the C here now? C is nothing but capacitance of a capacitor, which is epsilon naught A by D. So capacitance directly proportional to A, capacitance inversely proportional to D. ఒక కెపాసిటర్ ది కెపాసిటెన్స్ ఎలా అనుకుంటామంటే, ఏరియా ఆఫ్ ద ప్లేట్ is larger, capacitance is larger. Distance is more, capacitance decreases. So this is the formula for capacitance. And Q is equal to CV. Just like Ohm's law, V is equal to IR atlano resistor lo, Q is equal to CV atla. Then let us discuss about series and parallel capacitors. So two capacitors are in series, which is connected to the potential V here. Okay. So potential gets divided here V1, here V2. So whatever the charge is there, okay, as there is only one way for the current to pass. Current itla valsinde. So ikkada kuda charge same, ikkada kuda charge same. Charge is same. Potential gets divided in series connection. This series connection, what is the condition here? Charge is same. Potential gets divided. So what is getting divided here? V is equal to V1 plus V2. I told you Q is equal to CV. So V is equal to Q by C here. That means V1 is equal to Q by C1. V2 is equal to Q by C2. Okay. Charge same. Series resistance lo itla current same. When series connection is there, current is same, potential is divided. Here charge is same, potential gets divided. So V is going to be Q by C parallel. Okay. Here this is Q by C1 plus Q by C2. Therefore Q gets cancelled. 1 by C parallel connection is 1 by C1 plus 1 by C2. This can be taken as CP is equal to C1 C2 by C1 plus C2. Sorry. This is series connection, parallel. I'm sorry. Series connection. C series. Okay, this is the formula for C series connection. C1 C2 by C1 plus C2. Whereas in resistance R1 plus R2 akkada daniki reverse vastadi ikkada. Hope you're understanding. So this is the connection where all the capacitors are connected in series. Now when the capacitors are connected in parallel like this, then what happens? And this is connected to the battery separately, having potential V. So now this potential is common here, and here also the same potential is there, because this is separately connected to the battery. Potential is going to be same. Charge is Q up to here. At this place, as the current is divided, charge is getting divided. Something is here. So what is the condition in the case of parallel connection? Potential is same, charge is divided. Here charge is same, potential is divided, so we add with potential. Here potential is same, charge is divided, so we divide charge in the case of parallel connection, which is Q1 plus Q2. You know Q is equal to CV, you know Q1 is equal to C1V. Similarly Q2 is equal to C2V, because V is same in parallel connection. हॅलो समीर हां होऊन दे मी कंटिन्यू करतो आता हां दे So Q is equal to CV and C parallel in V, which is C1 into V, which is C2 into V. V is getting cancelled here, which is taken as C1, C2. So this is the condition for parallel connection here. Okay, parallel connection ki the condition, series connection ki the condition. Whereas you consider in the case of resistance series lo emostundi telsa R1 plus R2 vastundi. Resistance parallel lo emostundi telsa R1 R2 by R1 plus R2. Just converse. Both are completely opposite. This is the story of your total remaining chapter. Let us solve some of the problems based on this.